All right, inclined planes. So we're going to talk about how simple machines, they do work, but they don't do the work for you, they help you do the work, okay? You're still doing work, but the machines kind of help you. It's pretty much, you look at the machine, you look at the design. In many cases, when you do work, it's force times distance, okay? When we talk about a ramp, we're going to focus on, a ramp is used to help lift heavy things. You know, if you were to take this heavy box and you had to lift it up like 10, 20 meters, you can't do that alone. It takes a certain amount of work to lift the box a certain amount of distance. What the ramp does, it's a machine where the work in the end is still the same. It takes a certain amount of work to get the job done. But instead of maybe you lifting up that box with all that force over that smaller distance, the machine is designed where you apply the force to that box, not as much force, but what's the trade-off to get that same amount of work? You got to apply less force, but over a longer distance. So let's take a look. So here's scenario one. Here's the ground. Here's like where you want the object to go, okay? So let's just say it's 10 meters. Use easy numbers, right? And the box, I'll just make up the number, it weighs, I don't know, 100 newtons. 100 newtons. So to do the work, the job to get from here to here, work equals, we're just going to go FD. Cosine theta is 0 degrees 1. So work equals force of 100 newtons times 10 meters. So to get the job done for the box to go from here to here is going to be 1,000 joules. So 1,000 joules is the amount of work we need. So even with the machine, it's going to be 1,000 joules of work. And no, the machine that I'm going to draw isn't going to do the work for me. It's going to help me do the work. Machines don't do the work for you. They make the work easier for you. So I can't lift that box that high. It's too heavy. So instead, we're going to draw this. Watch this. So again, I need to do 1,000 joules of work. So we're in the same height. Here's your 10 meters right here, right? I can't lift it that distance. So here's the trade-off. To get here from point A to point B, the big box, 100 newtons, I'm going to go a longer distance. So now instead of going 10 meters, now I'm going to go 20 meters to do 1,000 joules of work. Okay? So my input, right, what I do to the machine will cause the output. You're going to apply, right, a smaller force. So I'm going to show that with a lowercase f. But what's the trade-off? You're going to go a larger distance. And in the end, the smaller force with the larger distance will get me that 1,000 joules of work. So I'm going to take this box right here, put it here. 100 newtons. But I'm going to apply it over 20 meters. But notice right here, where's the ramp going to apply the force? Here, 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 action, reaction, here, action, reaction, here, action, reaction, here. So as you go up, the ramp will help push the box up for you. So you don't have to go like that, you just have to push up and the ramp helps you. So here's how you're going to do the work. You're going to go 20 meters to do 1,000 joules. Okay? So how much force are you going to apply? Solve for F. So again, divide on both sides, you're looking at only 50 newtons of force. So by going a longer distance with the help of a ramp, you're only going to apply 50 newtons of force instead of 100. Who's going to apply the force? Bigger amount of force. The ramp applies a large force over a smaller distance because the force is applied right here, pushed right here, boom, push here, push here, push here, push here, push here. So again, in the end, looking at it overall, I'll redraw it. So watch this. You want to lift the box 10 meters, 100 newtons of force, 1,000 joules of work. I can't do that. So instead, the trade-off is this. I have to apply a big force over a small distance here. Big force over a small distance. Can't do it. So the machine is designed where I travel a large distance and I apply less force, but the work is the same. Okay, so machines make work easier. Does that make sense? Is that clear? Here's another example in real life. You have a football stadium, Lincoln Financial Field, down where the Eagles play, or Heinz Field out in Pittsburgh where the Pitt Panthers play. I don't care about that NFL team, who cares? Here's the ground. Here I am. You know I'm cheap, so I get the cheap seats up top here in the upper deck. So how do I get from here to the upper deck? Can I jump? No. Do I take a one steep ramp up? No, because the ramp will be so steep, I'm not going, the distance is too short. And there's about 50,000 people that want to get, no, in the upper deck, about 30,000 people that want to get up there. So how do you think they designed those ramps in those stadiums? To make it easier for people to go up a high height, but also accommodate thousands of people. They have ramps, two types of ramps. Now, at Lincoln Financial Field, the ramps look like this. Watch this. Here we go. Boom, 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 boom. One, and I don't know the exact number. 1, 2, 3, 4, 5, 6, 7, 8. Look how far you gotta walk. Boom, 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 just to get to here. So the trade-off is, it's not that hard to walk up these ramps. You don't have to apply much force. So you apply a little force, but you're going over a big distance. But in the end, the work is the same overall. Now, other stadiums have like spiral ramps. And believe it or not, when we learn about the screw, which is another simple machine, it's a inclined plane wrapped around a cylinder, okay? Round ramps so people can keep moving, but it's very gradual. So you walk a lot, but again, you're applying less force over a larger distance to get you to your seat. So again, you're still doing the work. It's just easier and customized to make work easier for you. So this is what we're going to be talking about. The key idea of all these machines, work is the same, but we will get the friction and efficiency. Work is generally the same. It makes the work easier for you, okay? So with the ramp, you're going to travel a longer distance and apply less force, while the ramp applies a big force over a small area in the action-reaction force, okay? So watch this video, and this is what we're going to talk about. We're actually going to go out to the front of the building, look at the ADA ramps in the front of the building to talk about how we get people from point A to point B. The next video I'll make, hopefully tomorrow, we'll talk about mechanical advantage. Output force over input force. And then we get to levers. That's a little complicated. Well, it's not just a lot. I'll make a couple extra videos to help allow this material to sink in. So I hope this was helpful. We'll talk about this in class. At least you have an idea. Machines make work easier. They don't do the work for you. All right, and by the way, no machine is 100% efficient. We'll talk about that too. All right. Hope this video gets you started on the right track. All right.